Hey guys, welcome to Pre-Calc lesson 2.4, an important one on quadratic and absolute value inequalities. Before we get to the inequalities, let's review graphing and finding our roots and our y-intercept. So in our first equation here, what we want to do is we want to put this into y1. So I know you guys are familiar with that. What you also want to do is create a y2 equation and set it equal to 0. And the reason for that is because it's easier to find the intersection of two graphs than it is to find zeros. All right, so if I put y1, that quadratic, into my calculator, I get something that looks kind of like this. And I need to identify 3 points, P1 and P2, which will be my two roots, and then my y-intercept P3. All right, so let me just jot down the information. You always have to label your coordinates, P1, P2, P3. Well, to find P1 and P3, you're going to do second calc intersect. I wish I could show you the graphing calculator, but unfortunately I can't in this application. But it's going to ask you for the first graph, second graph, guess, hit enter 3 times, and it's going to give you the intersection. And it'll specifically say intersection. P1, I got -1, 0. If it doesn't say what to round to, our default is hundredth. So P2 is 1.67, comma 0. Now our y-intercept, we always get this from the table. And if you look at your table, it's always where the x-coordinate is 0. So in this case, I believe it's 5, 0, 5. Now we're going to state what the x-intercepts are. You can't just leave those points there. So x-intercepts, x equals -1, comma 1.67. And my y-intercept, y equals 5. Okay. Next, let's talk about our plus-minus lines. I know we did this a little bit last unit with domain, but we're going to take a very simple example here and kind of explain this process, hopefully make it a little bit easier. So first of all, it says, given the inequality x plus 4 is greater than 0, obviously it's easy to solve analytically. We're going to just focus on this new process. Solve like it's an equation, because what you want to do is get the critical values. So basically, pretend it's equal to 0, solve it, and obviously we get a -4. So that's the number that goes on the number line, right? You solve this equation, we get x equals -4, that goes on the number line. So now we need to determine, well, is this part of the number line positive or negative? And how about this one, positive or negative? How do we do that? Well, we do this right here. You choose a number on each side. For example, -10 and 0, right? Easy numbers to substitute into the other function. And then you test in the original inequality and determine the sign, positive or negative. So over here, I'm going to pick -10, and over here I'll pick 0. Because -10 is less than -4, and 0 is greater than -4. And what we do is we plug into this expression right here. I don't care what the value is, I just need to know if it's positive or negative. Okay, so here I'll do -10 plus 4, and that's going to equal a negative number. So this piece of the number line right here is negative. Then on the other side, I plug in 0. 0 plus 4 equals a positive. Again, I don't even care that it's 4. It's just that it's positive. So this piece of the number line right here is positive. Okay, great. Well, what part do I want? Well, it depends on the inequality. Notice this right here says greater than 0. So if it says greater than 0, that means I want the positive piece. And notice the inequality does not have an or equal to, so that just means open circle. Okay, so it's going to be an open circle. And I'm going to shade the positive piece of the number line. What's this one right here? Okay, so I'm kind of jumping ahead and doing all of this on this one number line. So obviously, the solution to this inequality would be x is greater than 4. Solving quadratic inequalities. I'm not going to read all these steps. I'm not a big fan of memorizing steps. So let's kind of go through this process. First thing we have to do when I have an inequality, number 1, I recognize, inequality, quadratic, create a number line. All right, I'll do that over here. I know there's going to be 2 roots on this number line, so I'll put those in. Now what I need to do is figure out what those critical values are. Well, how do you figure out what these critical values are? You take the original quadratic and set it to 0. Okay, so we got x squared plus 10x plus 21 equals 0. Factor it easy, x plus 7, x plus 3 equals 0. X is negative 7 and negative 3. So we just have to make sure we put these in numeric order. So a smaller one here, bigger one there. That gives me negative 7 and a negative 3. So now, how do I get the positive and negative pieces? Well, what I need to do next is I need to pick random numbers. This number is going to be less than negative 7. This number is going to be between negative 7 and negative 3. And this number here is going to be greater than negative 3. So try and pick as easy a number as you can. So less than negative 7, I'm going to pick negative 10. Between negative 7 and negative 3, well, I could pick anything in between there. Let's call it negative 5. You can't pick the negative 7 or the negative 3. Greater than negative 3, I can pick my 0. So now what I need to do is I need to test these in this expression. And again, it starts getting a little bit more complicated because now I have a trinomial. But remember, I just need positive or negative. So let's throw that in there. Negative 10 squared plus 10 times negative 10 plus 21. Okay, well, this right here is going to give me 100. That right there is going to give me negative 100. So I have 100 minus 100 plus 21. So that's positive. Negative 5. Okay, so I'm going to have negative 5 squared plus 10 times negative 5 plus 21. All right, well, this is going to give me 25 minus 50. So it's negative 25 plus 21. That's going to be negative. So this piece of the number line here is negative. And then over here, I'm going to test the 0. All right, so it's going to be 0 squared plus 10 times 0 plus 21. Well, 0 and 0 and 21, that's going to give me a positive. So this piece of the number line is positive. All right, so now, how do I know which pieces do I want? Do I want the positive pieces, in which case would be that? Or do I want the negative piece, in which case would be this interval? Well, that goes back to the original inequality. Notice this says less than 0. That means negative. That means I want the negative piece. So here to here. This is going to be my solution. The solution to this inequality right here is going to be negative 7 is less than x is less than negative 3. Okay, next one. So first thing I need to do, obviously, is I need to get these terms to the other side. So undo them. This is going to give me y squared minus 3y plus 2 is greater than or equal to 0. Well, again, first thing I want you to get used to doing, quadratic inequality, number line. 2 values on the number line. Now I'm going to factor. So I have y, signs are same, both negative, y minus 2, y minus 1 equals 0, y equals 2, and 1. I have to put them in numeric order over here. So 1 is less than 2. Now it gets a little bit tricky. Remember, I have to pick numbers that are not those key points, but in the interval. So 0 can go here. Between these, it's got to be 1.5. All right, you can pick any decimal between them. I think that might be the easiest. Then over here, maybe I can pick a 10. So I have to plug into this. Now, some of you might start picking up on a shortcut here when we talk about quadratics. If it's y squared, and you might have heard your Algebra 2 teacher say this last year, notice this piece is positive, that piece is negative, that piece is positive. So if it's positive y squared, or x squared, obviously, it's going to go plus minus plus every time. Notice up here, that was positive, plus minus plus. I'm showing the substitution because when we get into cubics and higher degree polynomials, we can't follow this pattern. But you can anticipate with these quadratics. So let's just plug in one more time just to show you the process. This will be 0 squared minus 3 times 0 plus 2. Well, that's a 0, that's a 0. I get a positive 2. So this piece is positive. plug in a 1.5. You might think, oh boy, this is going to be a pain because I have to do decimals. 1.5 squared minus 3 times 1.5 plus 2. Well, 1.5 squared, it's like 15 squares, 225. So 1.5 squared is 2.25 minus 4.5 plus 2. Well, that's going to be negative because 2 plus 2.25 is less than 4.5. So that piece of the number line is going to be negative. And then one more time, plugging in a 10, it's going to give me 10 squared minus 3 times 10 plus 2. And that's going to be 100 minus 30 plus 2, so I know that's going to be positive. So there again you have it, the plus minus plus. I'm probably not going to go through all this substitution anymore because I'm going to recognize my quadratics. And if it's positive, it's going to look like this, plus minus plus. If I happen to throw a negative in front, it's going to look like this, negative plus negative. Okay, wrapping it up for this example. This says greater than or equal to 0, which means you want the positive, and because it's got the or equal to, close circle. So close circle, I want the positive piece. I want this segment and this one as well. Two separate inequalities. I'm going to say x is less than 1 or x is greater than 2. There's my solution. All right, I'm going to do all of these, but if you get the hang of this, you can fast forward to the next section, but I'm going to go through in case you need a little bit more practice. All right, example 3. 2x squared minus 11x plus 5 is greater than or equal to 0. So first step is to get 0 on one side. Again, I'm going to need a number line. I'm going to have two values here. And notice, it's positive x squared. So this is positive, the middle is negative, and the end is positive. So I know it's going to go plus minus plus right now. I'll throw those in. I'm going to save us a little bit of time. Plus minus plus. So what's left for me to do is factor this. A little bit trickier. It's got to be 2x and x. Signs are saying both negative. It's got to be 5 and 1, right? So is it 5 and 1, or is it 1 and 5? Well, you need an 11. So if I do 5 and 1, that's going to give me 5x. That's going to give me 2x. Both those would be negative. That's not going to work. So I've got to put the 1 here and the 5 here because that's going to be negative 1x. That's going to be negative 10x. And those two would give me negative 11. All right, so 1 here, 5 there. This root gives me positive 1/2. This root gives me positive 5. Put them in numeric order. 1/2, positive 5. Now you just have to interpret the inequality. Greater than or equal to 0 means you want the positive pieces. And it's or equal to, close circle. So you can see these really start going pretty fast, especially if they factor. Sometimes you might have to do quadratic formula, make them a little bit more challenging to get the roots. But this one's going to be x is less than or equal to 1/2, or x is greater than or equal to 5. Okay? I'm just noticing up above, sorry, catching this now, that should be or equal to 9x squared minus 15x plus 4 is less than 0. Number line, we're going to have two values on that number line. Again, I recognize this is a positive x squared. All these are positive. We should throw in some negatives, but anyway, plus minus plus. Let's factor this. So a little bit challenging here, right? We got lots of options. 9x squared could be 3x and 3x. Could be 9x and x. What do I notice? I notice that the signs are the same. So since the signs are the same, I'm going to be like adding the terms together, not subtracting them. So I'm going to start by guessing 3x and 3x, because I think 9 might be just too large a value. I know both of these are negative. I need to get 15. So again, we've got choices here with 4. Could be 2 and 2. Well, if it's 2 and 2, that's a negative 6x, and that's a negative 6x. That's negative 12x. Not going to work. So maybe it's 4 and 1. Let's try it. 4 and 1. What do we get? Negative 12x there. negative 3x there. Well, guess what? Those do give me this. So that's good. And this will give me x equals 4/3. This will give me x equals 1/3. Put them in numeric order. 1/3 here, 4/3 there. What do you want? Less than 0, you want the negative. Okay, so it's going to be open circle. I want that negative piece right there. How do you write that solution? 1/3 is less than x is less than 4/3. Solving these graphically. And there's two methods, really. I'm going to focus on method 1, and that's getting it to 0 on one side. So method 1, what I would do is subtract the 10 over. So I have x squared minus 3x minus 10 is greater than 0. Now what I need to do is I need to put this here into y1. All right, and show me that you're doing that. There's not much algebra involved. We've already done all the algebra we're going to do just by subtracting 10. So it's going to go into y1. Then I need to make an accurate sketch. All right, so I end up getting something that looks like this. Again, I apologize, I can't show you this on the calculator in this app. And my roots are negative 2. So you can show that here. You can do P1 and P2, or you can just do this. This is fine. And 5. Now, we've actually just done the number line. This is what's cool about a number line. It's a one-dimensional representation of our two-dimensional graph. Here's my number line. Here are my two values. This piece is positive, this piece is negative, and this piece is positive. So what I like to do is I like to have my students copy this underneath and put a negative 2 here, put the 5 here, and this piece is positive, that piece is negative, that piece is positive. Again, it comes from where the function is. This is above the x-axis, positive. Below the x-axis, negative. Above the x-axis, positive. Now, what do we want? You have to interpret the inequality. All right, so by doing that, I look at this. Greater than 0. That's positive. So I want my positive pieces. Here and here. I think this method is much easier because this right here looks exactly like our number line. All right, so I just need to write that inequality. That's going to be x is less than negative 2 or x is greater than 5. So let me show you method 2. I just think it's a little bit more confusing. Method 2, use the original inequality. X squared minus 3x is greater than 10. You don't move anything over. The difference here is you put one side into y1 and you put the other into y2. So now you're going to get a graph that looks similar to the one on the left, but we have two graphs. Here's my xy. So my parabola kind of looks like this. There's y1. And y2 looks like this. So now what I need to do is I need to find the points of intersection. I should have mentioned this in my other graph. I put in y2 equals 0. Now this one you didn't really need to, obviously, because you could get those from the table. But a lot of times those will be decimals. Okay, back to this one. So I need to find these coordinates, P1 and P2. You have to go through your second calc intersect. And here, I want to make sure it's accurate. I got negative 2, 10. And this one is going to be 5, 10. Here's why this is, I think, a little bit more complicated, because I need to know where this piece is greater than 10. Well, greater than means above. So I'm looking where y1 is above y2. So here's y1 above y2. It's this piece here. And this piece is above y2. It's that piece. So now I have to make a number line from that. You're just going to use your x value, so negative 2, which is going to be the same as over here, obviously, and 5 goes there. So I've got negative 2, I've got 5, and I want this piece here and that piece there. Again, open circles, right? I should put open circles there because it's not what we're equal to. And then obviously this number line would give you the same solution. I just think it's a little messier to begin with if you look at the right side compared to the left side, and it's a little bit more work. All right, let's do this example. I'm going to use method 1. So the first thing I want to do is get 0 on one side. This is going to give me 3x squared plus 10x minus 3 is less than or equal to 0. And this is what I'm going to put in the y1. It'll give me one graph. Okay, so let me check my calculator here. I get something that looks like this. There's my y1. And you're going to have to put in y2 equals 0 because these points are not real nice. Let's see, I got negative 3.61, comma 0. And this one right here, I got 0.28, I believe, comma 0. So again, what I want to do is I want to make my number line. I'm going to use those two values. Number line, this is going to be negative 3.61. This is going to be 0.28. And I need to interpret the inequality. I know by looking at the graph, positive, negative, positive. So I'll throw those in here. And notice here I want the negative pieces. Less than 0 is negative, or equal to is closed circle. Closed circle, shade this way. Okay, I don't have any more room underneath, so let me just write this out. Negative 3.61 is less than or equal to x is less than or equal to 0.28. And I'm done. Again, I'm doing all of these. It's a long video. If you get the hang of it, skip, move on. But I just want to make sure I get everything covered here. So this one, I'll subtract 4x from both sides. Gives me 4x squared minus 4x plus 1 is less than 0. I'm going to throw this into y1. Oops, sorry about that. All right, so now that gives me, graph kind of looks like this. This one's kind of interesting. And if you find this point, so there's my y1, sorry, there's y1. Again, what I'm going to do is I'm going to put y2 equals 0. I'm going to find this point there. That's 1/2. There's no other roots. This is kind of an interesting question. If we were to do this by substituting in on our number line, there's 1/2. What I would find is that it's positive here and it's positive there. It's positive everywhere on this number line, except the 1/2. So notice what this says. Less than 0. Where does this go below the x-axis? Where is it negative? Well, it's not negative here. It's not negative there. It's not negative here. That's equal to 0. So at no place, sorry about that, at no place is that negative. So the answer here would be no solution. Our next section on solving absolute value inequalities is a little bit more challenging. I really want you to focus just on the first step here. Again, I'm not a huge fan of steps and memorizing steps, but this is important. And I actually am not a fan of the wording here. Not equations, make 2 inequalities. So here's how it's going to work. And you might remember this last year. We did these last year in A2, believe it or not. If I have the absolute value of x is greater than or equal to 4, this first one here, I'm going to be real basic. I'm just going to guess numbers. Here's a number line. Okay, here's 0, 2, 4, 6, -2, -4, -6. I'm just going to guess numbers. Do they work? Okay, how about 0? If I put a 0 in here, the absolute value of 0, is that greater than or equal to 4? No, that's not going to work. How about a 2? Is 2 greater than or equal to 4? No, that's not going to work. How about a 3? No. How about a 4? That's going to be critical. 4, is it greater than or equal to 4? Yes, so 4 works. How about 5? Yep, 5 is greater than 4. How about 6? Yep, 6 is greater than 4. So it turns out 4 works, 5 works, 6 works. Obviously, any number in between there works. So all of these numbers work. 3.9 doesn't work. So one piece of our number line is going to be this. Well, let's try our negative numbers. Does negative 2 work? Well, put a negative 2 in. Absolute value of negative 2 is positive 2. Is positive 2 greater than or equal to 4? No, that doesn't work. Try negative 3. Is that going to work? No. Try negative 4. Absolute value of negative 4 is 4. Is 4 greater than or equal to 4? Yes. So negative 4 works. You get the idea. Negative 5, negative 6, so on and so forth. So this is the other piece of our number line. So look at what our solution is. I'm going to choose this piece first. That's going to be x is greater than or equal to 4, or x is less than or equal to negative 4. That is the solution. So what we have to do now is take ones that are a little bit more complicated and notice what we get. We have to rewrite this as an inequality. Basically, we just remove the absolute value. And the other one is you switch the direction and you negate that one. In example 2, we're going to rewrite this as two inequalities. One of them is going to be x minus 2 is less than 2, or x minus 2 is greater than negative 2. And we're going to solve each one of them. Well, this is pretty easy. Add 2 to both sides. I get x is less than 4. Add 2 to both sides. I get x is greater than 0. What comes next is a number line. Make sure you put these in numeric order. 0 is less than 4, so 0's got to go over on this side. There's 0, there's 4. Let's sketch these inequalities. X is less than 4. What's that look like? That's going to be an open circle, shaded to the left. X is greater than 0. Open circle, shaded to the right. Well, this looks kind of weird. What is the solution? Well, the solution is going to be where these overlap. So between 0 and 4. That's going to be here, open circle in between, basically this interval. 0 is less than x is less than 4. Okay, let's try a couple more. This one here should be pretty straightforward. First inequality, 2x minus 6 is greater than 8, or 2x minus 6 is less than negative 8. Add 6 to both sides, you get 2x is greater than 14. Divide by 2, x is greater than 7. Or add 6 to both sides, 2x is less than negative 2. Divide by 2, x is less than negative 1. What does it look like on the number line? Negative 1 over here, 7 there. X is greater than 7. X is less than negative 1. What is the solution? Well, it's both of those pieces. Open circle shaded to the left from negative 1. Open circle shaded to the right from 7. X is less than negative 1, or x is greater than 7. Now this is where it gets really tricky. At first, not too bad. You set it up the same way. X plus 2 is less than or equal to 3x, or x plus 2 is greater than or equal to negative 3x. Now, a little bit different here. What I'm going to do is I'm going to subtract x from both sides. I get 2 is less than or equal to 2x. Divide by 2, 1 is less than or equal to x. I never like you to keep the x on the right side. It just gets confusing. I find so many mistakes from students that do this. Just flip it back around. So it's x is greater than or equal to 1. Over here, let's add 3x. So I get 4x. Subtract 2, greater than or equal to 2. Subtract 2, negative 2. Divide by 4. So x is greater than or equal to negative 1/2. So you think to yourself, okay, well, yeah, I've done this before, no problem. Negative 1/2 is less than 1, so negative 1/2 over here, 1 there. X is greater than or equal to 1, so closed circle shaded to the right. X is greater than or equal to negative 1/2. Well, this is kind of weird. Now, it turns out there's an extraneous root. One of these two is not really a solution. All right, now some of you might figure out it's going to be the negative. Well, why is that? Well, because if you plug a negative 1/2 up here, you're going to take the absolute value of something, so you're going to end up with a positive because it's absolute value. Well, plug a negative in here, you can get a negative. So can a positive ever be less than or equal to a negative? No. So this is our extraneous root. But do you have to go through that process every time? Not really. If you want to throw in a number that's between these, let's test a 0. Just put a 0 up here and see if it's true or false. So I get 0 plus 2 is 2. Is 2 less than or equal to 0? No. So this doesn't work. That means this section of the number line is false, and our only solution would be this one right here. So I don't care how you come up with this. You could just test a number in between them, or you could just test for extraneous roots. But our only inequality here is going to be x is greater than or equal to 1. Okay, now graphically, once again, we're going to have both methods. And I think it's probably easier if you use method 1, where you have a 0 on one side, but that's not the only one that'll work. So let's take a look at absolute value 3x plus 5 minus 10 is greater than or equal to 0. And first thing you're going to want to do is throw that into your calculator. So if I do that, sketch it here, let me just show you. This is going into y1. All right, so I get something that kind of looks like this. And once again, I would put y2 equals 0 into your calculator and find these points. Those are going to be our roots. This is negative 5, I believe. And this is 1.67, if I can read my calculator correctly. So again, the key here, all right, if you notice this, the reason I like method 1 is because I can make a number line right now. There's negative 5. There's 1.67. And look at your function. Above the x-axis is positive. Below the x-axis is negative. And then this one's above, so it's positive. So I've got plus, minus, plus between those values. Plus, minus, plus. That's where it comes from. So once you've established that, all you need to do is go back up here and look, what piece do you want? If it says greater than 0, you want the positive pieces. And it also says or equal to. So that just means closed circle. And you want the positive pieces. Because we want the pieces that are above. We want the positive pieces. Okay, so let's just write that inequality out. I don't have much room, so let me do it here. This is going to be x is less than or equal to negative 5, or x is greater than or equal to 1.67. In example 6, what I'm going to do first, I don't even want to try the two-graph method here. It just gets too confusing. All right, so what I want to do is subtract this 4x over. That gives me absolute value 2x plus 7 minus 4x is greater than 0. And I'm just going to throw this into y1. You can get some goofy looking graph, but don't freak out. Get something that kind of looks like this. There's y1. I would put in y2 equals 0. I'd find this point of intersection here. That's the only part that you really need to label for an inequality. And I got 3.5. So again, the reason I like the one graph method, it lends itself very nicely to a number line. My number line is going to have one number on it, and that's 3.5. Now again, here's how you get it. Look at all of this stuff here is above. Well, actually, all the way to that point. All of this stuff is above. All of this stuff is below. So my number line is going to be plus, minus. That's it. There's only one number there, so I only have two intervals. Well, according to the question, you want the piece that is greater than 0. That's positive. So I want the positive piece. Notice it's not or equal to, so that means open circle, shaded this way. And that would just be x is less than 3.5. Okay, that's the end of it. Long lesson. I appreciate you guys hanging in there. As usual, guys, if you have any questions, don't hesitate to reach out via Brave Square or email. Thanks for watching.